Hello everyone, this is Gautam from Shailaja IS. The issue that we'll be discussing here is the PSLV problem. PSLV stands for your Polar Satellite Launch Vehicle by your ISRO. Why it was in news? The very first launch mission of PSLV in 2026 that ended up in a failure. So it was carrying actually 16 satellites as its payload, and all the 16 satellites were lost. One of the satellite was from your Indian military, which was important for your strategic purposes. Also, it is a second consecutive failure. The last mission in 2025 was also a failure, and the first mission in year 2026 was also a failure. So that is why your PSLV is in news. In this video, we'll try and understand the background behind your PSLV. What is the basic science behind your satellite launch vehicles? What is the importance of your satellites, or the basic science or the working principles behind it? We'll try and understand what are the factors that has contributed to the failure of this PSLV mission for 2 consecutive times. We'll try and understand what are the implications or the consequences of such back-to-back failures. What impact it is going to have from an economic perspective and from your strategic perspective. And finally, we'll try and understand what structural measures can be taken in order to prevent such failures to occur in future. First and foremost, we have to, I think satellites, I think everyone knows, it's a man-made object which orbits around your Earth for multiple purposes, for your weather forecasting purposes, to understand the forest cover purposes, to discover your resources, for communication purposes, for military purposes. So there are multiple purposes for which satellites are being put into the orbit. Now the science or the working principle behind it is very simple. I think everyone knows about gravity. The moment you throw a ball, it is not going to travel infinitely. It is going to fall back to the earth because of gravity. The faster you throw, the longer distance it is going to travel and fall back to earth. I think that basic principle everyone knows. If you throw slowly, it is going to fall at nearby place. If you throw at a much faster pace, eventually it is going to travel a large distance and travel at a much farther distance because of your gravity. Now, according to your physics, if the speed reaches around 7.8 kilometers per second, the object will perpetually travel around the earth. That is the basic principles of the working of your orbit. Gravity, and if the speed is achieved to a certain extent, obviously it is going to keep circulating around the earth and it is not going to fall back to the earth. The basic idea is to achieve that particular speed. That is your 7.8 kilometers per second. So in 1 second, the object has to travel 7.8 kilometers so that it continues to travel across the orbit. Escape velocity, I think most of you might be knowing. If the speed exceeds that, then it is going to escape the gravity of the earth and it is going to maybe travel to moon, travel to Mars or other Jupiter or other you can say planetary bodies. Right? So this basic principle should be known. Now what is the purpose of these launch vehicles? We'll try and understand. Or how these satellites are actually put into the orbit, we'll try and understand. See, ISRO designs a plan for this rocket. So it basically gives you the blueprint of a rocket. Now, what is a rocket or a satellite launch vehicle is nothing but your rocket. Okay? Rocket or your satellite launch vehicle. It can either be polar satellite launch vehicle or geostationary satellite launch vehicle. The difference is just how this you can say satellites are orbiting across the earth, whether it is going from pole to pole or whether it is going across the equator. That's the difference between your polar orbits or your geostationary orbits. We'll come to that again once more, but first let us try and understand what are these satellite launch vehicles, or in common words, what are these rockets trying to achieve? It is nothing but a truck which is trying to deliver the goods. Now, what is the purpose of the truck? You load your goods from one place, go and deliver it in another place. That is the purpose of the truck. Same is the purpose of the rocket. It is loading your satellites into itself, and it goes to an orbit and it delivers that satellite into the respective orbits. That is the whole purpose of your rockets or your satellite launch vehicle. The entire design of it, the working of it, the principles of it, what component needs to go in, which materials needs to be included, what fuel needs to be used, the entire science, the physics, the material component, everything is planned by your ISRO, which is our India's National Space Research Organization. Right? Now, once this design is done, it then goes to the second stage of manufacturing, where all these components are manufactured by either your public sector enterprises, that is government owned enterprises, or nowadays they are also trying to outsource this manufacturing to your private players. For example, they are given you, I think thousands of components are going to be there. Finally, all these components are going to be brought together in one place, which is your launch station. Currently, it is in Sriharikota of Andhra Pradesh, near your coastal region. And it is going to be assembled into a rocket. Now, this rocket is going to be having 4 stages. This Polar Satellite Launch Vehicle, which has been developed by ISRO, is having 4 stages. Okay, the first stage, second stage, third stage, fourth stage, and finally is going to be your satellites. Okay, it is not just it can carry one satellite, can carry 10 satellites at one point of time. Your Polar Satellite Launch Vehicle launched 104 satellites at a time in a single mission. When it took off from the Earth, it was able to launch 104 satellites. This entire PSLV has been in operation since the early 1990s, and it has been considered as the workhorse of your ISRO. The reason being, there has been 60 missions in the past 3 decades. It has launched hundreds of satellites, and the success rate is around 95 to 97%. So majority of the missions have been a huge success. So when there is a historic, you can say successive track record, obviously it is going to entice interest from other players. If your bus is able to transport your goods from one place to another place, and in a safe manner, in a cost-effective manner, obviously everyone wants to board on that particular truck or particular bus. The same is the case with your Polar Satellite Launch Vehicle of your ISRO. Now, coming to the, you can say the scientific principles behind it. See, it is weighing around 280 to 350 tons. 1 ton is around 1000 kgs. So 280 to 350 tons means around 2.8 lakh kgs to 3.5 lakh kgs. Okay, why is the variation? Depending upon the satellites on board, depending upon other things. Okay, in this, 90% of the weight is your fuel. 90% of the weight is fuel. Now, why do you need fuel? Because once you burn huge quantity of fuel in a very small amount of time, it is going to give you so much of acceleration and thrust that it reaches that speed. Okay, 7.8 kilometers per second is not a small speed to be achieved. Okay, and it achieves it in a gradual manner. The first stages, it burns huge quantity of oil. It is a solid fuel. Second stage is your liquid fuel. Third is again solid, and fourth is again solid. So out of these 4 stages, 3 stages are having solid as your fuel, right? Now what is happening in the first stage? It burns this entire fuel, it gives a massive thrust, takes off from the ground, travels up to 50 kilometers, by that time your entire fuel of your first stage is burnt. So whatever is the outer shell that is remaining, it gets detached and it falls off into the nearby ocean. And that is going to, you can say, drown to the bottom of the sea, and it is going to be discarded. The remaining three parts is going to travel further 100 kilometers, and when it reaches at around 150 kilometers, the second part is going to get detached because its fuel is spent, and the further two is going to move ahead. So in the successive stages, your weight is going to get reduced. As a result, the speed is also the vehicle is going to become more and more lighter, and you're going to achieve better speeds. So that's the idea. Third stages at around 300 kilometers, it is going to go. Finally, at around 350-400 kilometers, the fourth stage is going to launch your, you can say, satellites, and it would have achieved that particular speed. So initially it will be around 5 kilometers per second, then 6.5, 5.8, then 6.5, and finally 7.5 to 7.8 kilometers per second to put the satellites into the circular orbit around the Earth. That is the basic principle that you all need to know. Now you might ask, now what happens to this launch vehicle? See, the first stage is going to get detached after 50 kilometers and falls into the ocean. The second, third, and fourth, what are the stages? They're going to get detached and they're going to burn up in the atmosphere because of the speed that it has achieved. Because of the friction in the atmosphere, it is going to get burnt and get dissipated into the atmosphere itself. So every rocket launch, it is doing its duty and it's getting depleted. So 60 missions ISRO has carried out, in the sense 60 times rockets have been filled. Why it is still considered as a workhorse? Primarily because the design and the manufacturing process has been so detailed and so put into the place that there is a sense of trust and consistency that can be expected out of this satellite launch vehicle. The recent, you can say, technological developments in this particular field is that what your private space company, your SpaceX, which is headed by your Elon Musk, has achieved, it is going to launch and it is going to again come back and safely land on the Earth. So that type of technological advancement has been achieved by the humanity, more particularly by your US private space company called as your SpaceX. I think most of you might be aware about it. India is still yet to move towards your reusable launch vehicle. All these launch vehicles are going to get depleted in one mission. It is like you're going to deliver the goods, that's it, your mission is finished, your mission is completed. For another, you can say launch mission, it has to be again, entire design and manufacturing process has been put in place. So it has to be again assembled, again put into the place, same relaunch is going to happen. So this basic principle is what is expected out of you to understand about this polar satellite launch vehicle. Now why it is called as, I think this pictorial diagram clearly explains you. At around 50 kilometers, first stage is going to get detached. Around 50 to 100, under 150 kilometers, second stage is going to get separated, and 5 kilometers per second speed is going to be achieved. In the first stage, it's actually around 2 to 2.5 kilometers per second. And in the third stage is going to get separated around 300 kilometers, and it's going to achieve the speeds of around 7 kilometers per second. And finally, in the fourth stage, it might be around 300 to 400 kilometers. Your final payload is going to get deployed, right? Now, polar satellite launch vehicle means it is going to launch your satellites in a polar orbit. That is, it is going to go from poles to poles. If you can clearly see, okay, you can clearly see the satellite is moving across the poles and the Earth is rotating. So eventually what is going to happen with so many revolutions, it is going to cover the entire surface of the Earth itself. So that becomes important for your remote sensing purposes or trying to understand the activities across the globe, right? So this is going to be placed in a low Earth orbit, which is around 300 to 400 kilometers. Another, you can say, orbit is your geostationary satellite, which revolves across the equator, and it's going to be at a very high altitude of around more than 3,000, 36,000. You can say the more long orbits. Okay, And your polar satellite launch vehicle is versatile in the sense it can launch your orbits even in your low Earth orbits, or it can launch in your high Earth orbits also. Okay, it can take to a much farther right, and it can launch the satellites over there. Now you can ask how it is possible. When it is launching at a much, you can say, larger orbit, the payload weight is going to be reduced. As a result, it can travel much longer distances. So this basic background is necessary for you to understand all the space missions that you can come across. All you need to know is the purpose of your satellite launch vehicles. You need to know the basic principles, that is the gravity principle that is helping the satellites to stay in the orbit, and you need to understand the different types of orbits, that is your polar orbit and your geostationary orbit. Now, as I told you, PSLV has been highly reliable, 60 plus missions, hundreds of satellites have been successfully launched. It's versatile, it can be put in your polar orbit or in your geostationary orbit, and it has been your global favorite. Other countries wants to launch their satellites using this PSLV because it has time and again proved that it is going to be cost effective, reliable and successful. Some of the historic missions that has been launched through these launch vehicles were your Chandrayaan mission, the mission which finally went to the Mars, for your moon, and your Mangalyaan mission which went to your Mars. Okay. Now, what can be the factors which has led to back-to-back two consecutive failures? See, they are still trying to investigate. Primarily, you can say that the failure is happening at the third stage. Apart from the technical aspects which is going to be revealed through your thorough investigations, we'll try to understand basically from a bureaucratic perspective or a general studies aspirant perspective, right? First and foremost, you need to understand ISRO is now undertaking many missions. It wants to send people to moon. It wants to create its own, you can say, space stations. It is wanting to send, you can say, missions to Mars or other places. As a result, it is occupied with multiple programs. Earlier, what used to happen, it used to concentrate only on the few missions. Now it is concentrating on many missions. First fact. Now I'll tell you what is going to happen because of this. Second thing, it has also increased your launch frequency. Earlier, if it was launching twice or thrice in a year, because of the commercial aspects, because of high demand across the world, the launch frequency has also increased. Now, when you're focusing on multiple missions and at the same time your launch frequency also has increased, your resources are going to spread thin. Earlier, for example, 10 people are working on 3 missions and your launch frequency was only 2. Now, the same 10 or 12 people are going to work on 10 missions and 5 to 6, you can say, launch frequency. So obviously, the resources are going to be they're going to spread thin, they're going to work under your constraints. As a result, the focus might have been diluted, is one of the factors which could have led to this failure. Another aspect is your testing infrastructure bottlenecks. With increased demand, with increased launch frequencies, your testing facilities also needs to ramp up in a quick manner. That is being felt inadequate with regard to your India's space ecosystem. Also, there are arguments that whatever is the technology or the components or the manufacturing processes that we are having is actually aging faster, and there is a need for upgrading those technologies and upgrading those components, right? And finally, there is a talent drain to private sector. The government is, you can say, pushing the private players to operate in your space field. Why? There are, you can say, concrete arguments for it. As I told you, ISRO is in designing stage. It is also involved in your manufacturing. It is also involved in your launch. They're saying that why are you focusing on manufacturing? Why are you focusing on launching? This all should be privatized. You should focus only on designing and exploration and expanding the scope of human understanding of the space itself. You should be focusing more on your design. And that's the reason the government is saying, let us hand over whatever knowledge you have acquired to launch successful missions to private players. They'll take care of it. It's a set process. It's a set methodology. Maybe they'll innovate and try to do it in a more cost-effective manner. You don't have to worry about all this manufacturing and launch purposes. You focus more on your research purposes. And that is what should be the intention of any national space agency, to push the frontiers of human understanding of the universe and space. So that they're saying that some of the talent are going to your private sector, and maybe that has created a resource constraint in order to go for a thorough check before your launch vehicles. So there are multiple factors, as I told you. The resources are overstretching across multiple missions, increased launch frequency pressure, testing infrastructure is not keeping up with the pace, aging technologies, and finally your talent drain to your private sector. All this can be a possible contributing factor for your PSLV failure, right? Now, what can be the implications of this? What are the consequences of the launch vehicle failures? First and foremost thing is the immediate implication is your strategic defense. There's going to be a gap in it because one out of 16 satellites was from your Indian Army or Indian military. As a result, it is going to impact our defense capabilities. Second thing is that whatever is the hard-earned prestige of successful PSLV launch missions, that is under threat. If another one or two failures, obviously, what all trust or the commercial trust that we have earned over the past two, three decades is going to get eroded. Primarily because there is an intense competition from your private sector. Your companies like your Blue Origin or your companies like your SpaceX, who are from a private sector, they are providing these launch vehicle services to other countries, right? So there is intense competition, and if you don't keep up with the delivery part of it, the commercial trust that you have earned or the ardent prestige that India has earned is going to get eroded. And more importantly, the revenue is also going to get impacted. New Space India Limited, which is in charge of trying to get this commercial, you can say, agreements in order to launch satellites into the orbits using this PSLV platform, they might be finding it difficult to get new buyers, right? So its revenue is going to get impacted. And obviously, what is going to happen? Your insurance cost is going to increase. Okay. And if your insurance cost is going to increase, obviously your profit margin is going to increase, or you might have to push up your cost. So again, economics is going to come into picture. And in order to decode what exactly went wrong, what fixes has to be put in place, it is going to take us some amount of time, and that can delay the future operations, right? So all this has some of there is strategic consequence, there is soft power consequence, there is economic consequence, and there is also operational consequence because of this failures. So what needs to be put in place? First and foremost, you try to delineate you can say separate or the role of, you can say, research, designing with regard to your manufacturing part of it. So clear separation of roles needs to be established. There needs to be greater technological transfer to the private sector. Testing infrastructure has to be increased, and we need to go for an upgradation of your PSLV technology. And more importantly, we need to have an independent quality assurance audit in order to understand the performance of all these launch vehicle missions, right? So that is all about this issue. I think you got a fair bit of an idea. From a generalist perspective, you need not have to be an expert and you need not have to explain the exact mechanisms behind it. But if you are able to understand the working principles behind it, more than enough for you, right? See, for each of these issues, we are actually releasing a visual summary or an infographic. In one particular image, we are trying to provide the concise information. So whatever I discussed in this 15-20 minutes has been summed up and put it in just one image, which is going to help for your quick revision and quick retention purposes, better retention purposes. And we are also releasing from January 2026 an infographic magazine, which is a collection of all these infographics. So you can download from our Telegram channel, right? There's one question. Reliability is the currency of global space market. That's a quote. In the light of recent PSLV setbacks, examine the commercial and strategic implications for India's space program, and what structural reforms are required to ensure ISRO balances its scientific goals with commercial obligations effectively. So basically, they're asking your consequences and way forward. I think with all the points discussed, you will be in a better position to attempt an answer. So if you want to attempt it, please attempt it and send it to my WhatsApp, or you can email it to me. Here are the details. All the very best. Looking forward for your queries or doubts or answers, right? Thank you.